Hi, I'm Yusuf Abdullahi and I work as a tutor at statisticassignmentexpert.com. I'm going to explain to you a solution of assignment that is based on logistic regression. So in this assignment, we are to use a SAS data set to estimate a data. Then we are going to calculate the probability um, of positive outcome, and then we are going to find the predicted value and the confidence limit. I'm going to show you how to test for hypothesis by hand, and I'm going to show you how to estimate the 90% word confidence limit of the odd ratio when x is increased by 1. So I have 9 questions that I will follow here. So um So the first question is that find the estimate of the probability of y equals to 1 given x. So in order to do this, the first thing is to estimate your logistic regression model using SAS, and this is what we have done here. We can see that this is the intercept. The intercept estimate is minus 10.6480, while the independent variable is 0.1979. Then standard error this one. So in order to estimate the probability of y equals to 1 given x, this is the formula we are going to use. Is 1 over 1 plus exponential of minus b exponential of minus beta naught plus beta 1x. So we have oh, so we have this. So what is our beta naught? Our beta naught is the value for the intercept, and our beta 1 is the value for the slope. So the probability of y equals to 1 given x will be 1 over 1 plus exponential of minus 10.6480. We just substitute this value here plus 0.1979x. Since we are not giving a specific value of x, we are going to stop here. So we won't have a specific answer. This is a general answer. Then if we are to find probability of y when x is equals to 20 or equals to 30, then we can now substitute y and get a specific value. Then for question 2, they say what is the R squared of the model? R squared of the model is automatically calculated by SAS, and so the result here from SAS say that the R square is 0.4782. So we see that the R square is 0.4782. Even though for a logistic regression model, we should be very careful in interpreting the R square. So the R square is not valid like the R square in the linear regression that we have. That's the R squared of the model. Then the third question is that find the predicted value and the 99% confidence limit for the probability of y equals to 1 given x equals to 40. So the first thing we have to do here is from this result in equation 1 over 1 plus exponential of this x, we just substitute the 40 for x, as we will see. So we see that if we substitute the 40 for here, so evaluating this, we see that our probability of y equals to 1 given x equals to 40 is 0.061. Then to now determine the confidence interval, that is to determine the confidence the confidence limit. We have exponential of g of x plus 1.645 times standard error 1 plus g of x plus or minus 1.645 times standard error of gx. So then what is our gx? Our gx is the estimated probability, that is 0.061. Then the standard error of gs is given as the estimated variance of beta naught multiplied by x squared times variance of beta 1, and then 2x are covariance of beta naught and beta 1, where the variance of beta naught is what? The square of the standard error. That's we have our standard error from the result here, 2.1085, 2.1085, yes, 2.1085. Then the same for variance of beta 1 is standard error of beta 1 square, which is 0.0398 as we see here. And then we see that our covariance of beta naught and beta 1 is the correlation between beta naught and beta 1 multiplied by the standard error of beta naught and standard error of beta 1. So this is given by so this 0.68184 times 2.185, 0.0398. So we have 0.057. Then the standard error of gx will be this plus this multiplied by 40 squared plus 2 times x, which is 40 times this. So our answer, we have 3.399997. So the confidence interval is now, so from the formula we wrote 1.645 here, but it is z alpha alpha all over 2. So it is the critical z value that we are going to slot in here. So that is the critical z value. No, but 1.645 is the z value when we are talking about 90% confidence interval. So but here we want to look at 99% confidence interval. Then it means that that's 0.1. So the z value for 0.01 for 2-third, that will be 0.005 is 2.5758. Then so we have from the formula here, so we have exponential of gx. Let me copy it here. So we have exponential of gx. Our estimated gx is what? The probability we estimated, that's 0.061, then plus or minus our z alpha over 2, that's 2.5758. You can see that in a normal distribution table. And then the standard error we calculated is 3.397. Then all over 1 plus exponential of gx plus or minus as above. So we can see here that the 99% confidence interval, so we now separate the negative is for the lower band while the positive is for the upper band. So our 99% here is, if we calculate all this, we get 0.0016, 0.999. So the probability of y equals to 1 when x is 4 is 0.0611, and then the confidence interval at 0.00016 and 9998. So this means that the interpretation of confidence interval is that we are 99% confident that the probability of y equals to 1 when x is 40 for the whole population will be between 0.00016 and 0.998. So the next question D, say we should find the predicted value and 99% confidence in our limit for the probability of y equals to 1 given x equals to 17. So we can estimate for x equals to 70 here. So we see that using our formula, we just have to substitute 70 for x here. So we substitute 70 for x here. So we have 1 over 1 plus exponential 10.648 is 0.1971 times 17. Then we have probability of y equals to 1 giving s equals to 70, which is 0.961. Then that's the point estimate. Then we now get the confidence interval the same way we went to it the other time, the same way we calculated all these. So we calculate again. So we have from our calculation the standard error of gx. I did not show all the workings here, is 4.496, but it is pretty simple. What you have to do is all these are the same. The only thing you need to do is to substitute 70 here and 70 here, so you get your answer. So we have 4.496 times 2.578 this, and when we calculated this, we see that our 99% confidence interval is between 2.44 times 10 raised to power minus 5 and 0.0099. So the interpretation is the same, that we are 99% confidence that the probability of y equals to 1 given that s equals to 70 for the whole population is between 2.44 times 10 raised to power minus 0.5 and 0.999. So for question E, so we need to find the p-value for testing hypothesis h naught beta 1 equals to 0 against beta 1 is not equals to 0. Actually, the software have provided this for us. Less than, so the probability is less than 0.01, but we can come here and see, in order to test for B1, so we will construct the test statistic as z equals to beta 1 estimated beta 1 minus 0 over standard error of the estimated beta 1, and we can see from here that the beta 1, which is x, is 0.1979 and the standard error is 0.03398. So what do we have? So what we do is, then z is 0.1979 over 0.0398, that's 4.972. so the p-value for z equals to 4.972 is 1.706 for exponential of minus 6, which is something like 0.0001706. So that is why SAR said it is less than 0.001 because it's too close to 0, as you can see here. Then the next question states that what is the estimated net value and 90% what confidence interval, what confidence limit of odds ratio when s is increased by 1 unit. So the result shows that this is gotten from Starter, And another way is that apart from getting it from starter, you can actually say exponential of this. It will give you the odds ratio. Let me demonstrate it for you in Excel. So we have exponential of what? Of 0.197979. So that's 1.2188841. So let's compare. So you can see 1.2188, that's 1.219. And then the software calculated the 99% word confidence limit for the two. So we can see that the odd ratio is 1.219 and the confidence interval is between 1.1 and 1.35. So this means that a unit increase in x increase the odds of y by 1.219, and we are 95% confidence interval that a unit. So this is the interpretation. The interpretation of the point estimate for the odds ratio is that a unit increase in x will increase the odds of y by this amount, by 1.219. Then for the confidence limit, we say we are 99% are confident that a unit increase in x will increase the odds of y for the whole population by a value between 1.1 and 1.35. Then we have the next question is that what is the p-value of testing the hypothesis that b0 equals b not equals to minus 10 against b1 is not equals to minus 10. So we go here, we calculate this z statistic the same way we do calculate it. So that will be the estimated beta naught minus the hypothesized value, that's minus 10 all over standard error of beta naught. So from our earlier estimation, we see that for the beta naught is our intercept, and the estimate here is minus 10.6480. The standard error is 2.1085. So we come back here. So we have this is the b naught, and this is the 2.1. This is the standard error. So calculating it, we have that we see that our z is 0.307. Then using a p-value calculator, we see that the p-value for this is 0.381, which means we cannot reject the null hypothesis that beta naught equals to minus 10. So it means that the intercept is not different from minus 10. Then the next question state that what is the p-value for testing hypothesis h naught beta 1 equals to 0.3, beta 1 is not equals to 0.3. Okay, before I go to that place, let me show you how you can calculate p-value using Excel. So since it is a normal distribution, we said norm distribution sorry, I have norm inverse sorry, I use norm x distribution. So I will just input my z value. So I have minus 0.307. So what do I have? So I have 0.379, which is actually closer to this. So I have this. So I use norm-S distribution. Okay. So then the question G is stating that what is the p-value for testing hypothesis H naught B naught, sorry, what question H, what is the p-value for testing hypothesis H naught? Beta 1 is 0.3 against beta 1 is not equals to 0.3. So we can do that the same way we did this. So this question H not G. So to test this, we construct this test statistic as the estimated beta 1 minus the hypothesized value all over standard error of beta 1. So I have 0.1979 minus 0.3 all over 0.0398. Where did I get this value? I got it from here. 0.1971. That's the estimated x, and then 0.0398 is its standard error. So I have minus 0.1021 over 0.0398, so which is minus 2.565. Then the p-value for z is minus 2.565, and the p-value for this value of z is 0.0149 using the p-value calculator. So let's see if we get something close here. So our z is minus 2.565. So what do we have? We have 0.0. So something is so if we approximate, we see that we are having we have the same approximation, 0.01 and 0.01 to 2 decimal places. So that's then the last question states that draw a plot of predicted 99% confidence interval. Yes, of course. So then this plot is gotten from the graph, and this plot, you see that this follows a logistic distribution, in the sense that you can see the shape, that this is the shape of logistic curve. So these points are the observed value, because our dependent variable is binary 0 and 1, which is what is required for a binary logistic regression. So we only have 0 and 1. Then the probability span from 0 to 1. So as we can see, this takes the shape of a logistic regression model. So we can trace out that at x equals to 60, we can trace out that the probability is around 0.75, and when x is 80, the probability is actually close to 1, and when s is 40, the probability is very low, around 0.06 or something like that. So that is what I have for you on this. So for any assistance with statistical assignment, you can email to support@statisticassignmentexpert.com. Thank you.